In this screencast, I will show you how to visualize results from REEF3D CFD. I'm going to choose a random CFD simulation, a 3D simulation with a cylinder in the domain, and show you how you could visualize this in different ways. So let's first open the folder. So the folder REEF3D CFD VTU has the output that can be read using Paraview. You can see the types of files here. The bookmarks PBTU consists of all the combined parallel files in one place. So if you close this, you open all the files that were generated in the simulation. The VTU files after that stand for the outputs that are generated according to your command in P30, P20, or P35. So in this particular case, it's just a trial, so there are only two output files. So I'm not going to make a video, but just show you how this is working. If I click this arrow here, there are 4 parts. So this simulation was run with 4 processors, that is M10-4. And that's all combined into one, that's all under one VTU there that belongs to that particular time step. The same thing here for time step, the second time step, there are results from the 4 processors. All these files here are combined in the PVTU file. So you generally just need to open the top PVTU, the combination of all PVTUs. So let's do that. And there it is, that's open. You can hit apply and immediately you get something like this, a 3D domain with that hole in the center where the cylinder is supposed to be. Okay, so that's the 3D domain. You see it's completely filled. This is where we start. All right. First, I will show you how to use the command or the visualization of a slice. On several occasions, a 2D plane along the x-axis is the most interesting plane, at least in this case. Say, for example, we want to visualize a slice that is running along the center line of the tank, so which intersects the cylinder in its middle too, in the center too. So here is the option for slice. Make sure that the CFD is selected. If it's not, you see you don't get these options. Select, and then you have the slice command that pops up. You get that tooltip hint. Click on slice. The default is set to an X normal slice. So the slice is normal to the X-axis and goes inwards along the Y-axis. What we want is a Y normal slice. So on the left-hand side under the properties, click on Y normal. And then you can see this slice is normal or perpendicular to the Y-axis and runs along the X-axis. So what we are going to see is an XZ plane. So X and Z, X running parallel to the bottom of the screen, Z running upwards. So let's hit apply. So you see that this eye is closed, which means it's not yet visible, it's hidden, and it's not applied, which is why the apply button is still blue. I hit apply, and now you can see that the big 3D object disappears and one slice is shown. So I hit then Y positive. So here in this part of the ribbon, the set view direction to +Y. What does that mean? The letter that is shown there refers to the axis that is going to be hidden from view. So in a Y normal plane, when we are looking at the XZ plane, what we see is the positive and of course the negative X-axis, and positive and of course the negative Z-axis. What you don't see is the Y-axis. If you switch to -Y, you see we are looking at it from the other side, Similarly, +X, you will see nothing because we have taken a slice on the XZ plane. +Z, the same thing, you see nothing. So coming back to +Y, so we have the XZ plane that is shown here. To get rid of those red lines, I will just remove the tick from show plane. You can scroll to zoom in here. So this is the gap here left by the cylinder. We can fill that. when you have an object in the domain, REEF3D will generate either a REEF3D geometry object.vtp if you use the O command, and REEF3D solid.vtp if you use the S command in dive mesh to generate the object. Click OK and apply. There is the cylinder. Now the slice is just plain without any colors. That's because it's filled with a solid color, which doesn't give you any information from the simulation. So let's have velocity. So then you get the velocity contours. And in velocity, you have the option to select X velocity, Y velocity, or Z velocity, or just the velocity magnitude. The color bar is right there. You can also edit how the color bar looks by going to the second one here, edit color map. You get a pop-up on your right, and at the top right corner you have edit color legend properties. Here's the title. Say if we are using the magnitude, I could just write view and remove this. If you want to plot the X velocity, you could use the LaTeX style, have two dollar commands, U_X, and you will get UX. You can just hit apply to show you the change in the background. You see UX that is applied there, but since I've chosen magnitude already in the main screen, I just use U. There we go, apply, okay. You can make other changes to the color bar right there. You can add the units and so on and so forth. So here now what you have is a slice in the X and Z direction, XZ plane, so to say. You want to look at the free surface, of course. So on the slice, let's get a contour. So the contour appears, and in the contour by, well, REEF3D uses the level set function to represent the free surface. So you go to choose 5, and the 0 value of the level set represents the free surface. So in the value range option, or the ISO surface option, you set in 0 and apply. That should give you this blue line, which is the location of the free surface. Of course, here now it's trying to color over 5. You don't need that. You can turn that to solid color, which will make it white. And because of my white background, it is going to disappear. Make slice visible again. So now we have the slice showing the velocities, and you have the white line that shows the free surface. The white line could be a little too thin. Maybe it's not very visible. So you can increase that thickness by just looking for line and scroll down. You will have line width. You can set it to 2, 3, whatever, hit enter, and you will have the line thickness increased. And therefore now you have the free surface. In this particular example, I only have 2 time steps, so you don't have a lot. Just go to the next one. You just see this, the simulation is just starting. Some deformation of the free surface has just started. So this is how you would visualize a slice from a CFD output. Another way to visualize the results would be to use the entire 3D domain. Since it's a 3D simulation, since we have a width in the y-axis that is calculated, we can also use a contour directly on the main file that was loaded. So let's select the first option there, CFD, the file that you initially loaded, and directly click on contour. So you get a new contour, do the same thing, contour by phi, and a value of 0 for the ISO surface, and click apply. And there you go, you have the free surface all in throughout the domain in that in that plane there. You can hide the line that you had from the slice. Maybe you feel that this looks a little strange, so you can have the outline of the flume shown. So let's make the entire domain visible and change the representation from surface to simply outline. You can see that the outline is drawn. The default color is white. Let me change that. Let's go to black. So when you use solid color and click on edit color map, you get to choose the color that you would want this outline to be in. So based on that, you can just choose any color for your outline. If you think that the outline is too thin, again, while the CFD, the top file is selected, which is represented here, click on line, you should get line widths. You can increase it to say 2, you get a thicker border. So this is the way you can visualize a 3D result and the 3D contour or the surface, the free surface around an object in the domain using the CFD output.